Hello everyone and welcome back. My name is Mr. Cobalt, and in this video I'm going to show you how to find the empirical formula for a given compound when you're given the grams of each element instead of the percentages. This problem is actually easier when you're given compared to when you're given the percentages because you have one less step. So remember, when you're given the percentages, you can convert the percentages to grams by just assuming you have 100 grams of your compound, and then the percentages work out to the gram amounts, right? But in this case, you're given the gram amounts, so you can skip that step. So you still go on to make your empirical formula by getting the moles. That's the goal, because since the empirical formula or any molecular formula or any formula is going to have a ratio, a mole ratio of one thing to the other, of one moles of one thing to moles of another. So we got to get it to moles. So here we start with grams. We've eliminated a step. So let's go ahead and convert the grams of each of these to moles. So I'm going to take the bismuth. I have 32.516 grams of bismuth, and I'm going to use the molar mass of bismuth to convert that to moles. So I look up the molar mass of bismuth, and the molar mass of bismuth is 208.98. So 208.98 grams of bismuth goes on the bottom, and 1 mole of bismuth goes on top. So the grams of bismuth cancels out. Now I have moles. So I can calculate the moles of bismuth, and when I do that, I get 0.1556. So that's going to be 0.1556 moles of bismuth. Okay, so now I can do sulfur. So I'm going to take sulfur. I'm going to take the gram, 7.484 grams of sulfur. I'm going to put that over 1. I'm going to multiply that by its molar mass. And sulfur again is 32.07. So I put 32.07 grams of sulfur on the bottom, and I put 1 mole of sulfur on top. The grams of sulfur cancel out. I have moles. So again, when I calculate that, I get 0.2334. So that's going to be equal to 0.2334 moles of sulfur. So now that I have the moles of each of the element, this will create my mole ratio. Right now, I have a ratio between these two, but it's not a simple whole number ratio. So I would like to have a ratio of 1 to something, right? So in order to do that, I need to divide one by the other. But first, since these are moles, these are my subscripts. So I'm going to have these as subscripts in my what is called a pseudo formula. So I'm going to write that up here. So my pseudo formula is going to be bismuth. Since that's the metal, I'm going to write the metal first, and then we have the non-metal. So then the subscript is going to be the 0.1556. And then for the sulfur is next. That's my non-metal. That's going to be 0.2334. So 0.2334. So there are my subscripts, my molar subscripts for my formula. Now, we don't like to have these fractional amounts. We like to have whole numbers. So I need to reduce this to get whole numbers. So in order to do that, I need to divide by the smallest one. Why do I divide by the smallest one? Because by dividing by the smallest one, I'm not going to get a fraction less than 1. I'll get something more than 1. And by dividing this by the smallest number, I'm going to get 1. So I'm going to get a ratio of 1 to something. Hopefully that's going to be whole numbers, but we'll see. So I'm going to divide by 0.155. I'm going to divide that by itself. That's the smallest one. And then I'm going to divide this by 0.1556. And the hope is that I'll get a whole number here. But if I don't, then I'll have to multiply by some factor to get rid of it. But let's see what we get. So if I divide this divided by itself, of course, is going to be 1. So that's going to be a 1. And then if I divide this, I get exactly 1.5. So sulfur, I get 1.5. Okay, so obviously not a whole number, but look, this is an obvious fraction. Again, I can't round this to 2. That's going to be too big of a rounding error. So, but it is obviously a half. So to get rid of a half, I can multiply by 2 and I can get that out of there. But again, this ratio, I want to keep the ratio, right? By dividing by the same number here, now my ratio is reduced to 1 to 1.5, right? I don't want to lose that ratio. So what I need to do is multiply everything by that factor. So if I multiply this by 2 to get rid of the half, then I need to multiply this by 2 as well. And so then I get bismuth 2, 1 times 2 is 2, and then 1.5 times 2 is 3. So this is going to be 3. And so, ladies and gentlemen, that is our formula. This is the empirical formula for this substance. And so if I was to name this substance, since it's obviously ionic, I have a metal and nonmetal, this would be bismuth sulfide. Bismuth sulfide would be the name of this compound. Oops. So bismuth sulfide. And that's it for this video. That's how you get your empirical formula when you're given the gram amounts of the elements in your compound. So if you have more than 2 elements, then you'll be given gram amounts of, if you have 3 elements, you'll be given gram amounts of 3 or 4 elements, whatever the number of elements. If you're given gram amounts of each element, then this is the process that you use to get to empirical formulas. I hope you enjoyed this video. If you learned from this video, if this was interesting, then please, by all means, like the video, share the video, hit that like button. Also, make sure you subscribe to my channel, hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below, please. Let me know what you think. Ask me questions. If you've got a certain question or a problem you want me to help you with, or if you've got a topic you want me to cover, I would love to do that for you. Thanks for joining me and have a great day.